Hey guys, so today we're going to look at page 8 in your packet. We're going to graph from standard form. So we already graphed from factored form. And so when we had factored form, we'd have our sets of parentheses and we could immediately pull those roots or those zeros and plot them on our x-axis. But that meant every one of our roots was a perfect whole number because it was in factored form. The reality is that's not always the case. Sometimes our roots fall between numbers and there are some type of decimal value, especially when we're dealing with things obviously that cannot be factored. Hence why we're going to keep them in standard form. Now, we can apply some of what we looked at yesterday to have an idea what's going to happen to our graph. So if I look at the first function, x cubed minus 3x squared plus 2, think about things that we talked about yesterday. We talked about using the degree to help us determine how many roots, also what happens with our end behavior. So if we think about those things, this has a degree of 3. That tells me that it's odd. If it's odd, that tells me that the end behavior is going to go in opposite directions, right? So my coefficient in the front is positive. So on the right side, I know I'm going to go up. On the left side, I know I'm going to go down. And because it's a degree of 3, I know I'm going to have 2 turns. So it's going to have to turn to make that happen. So I already have a rough look at what my graph is going to look like. I just have to figure out where on the graph it's going to happen. It tells us to graph using a table of values. So you want to start with a basic XY chart. Start with sort of the traditional center set of values, -2 through +2. Once you have those values, you may need to add a number or two above or below, depending upon your graph, to make sure that we're getting that end behavior and we have hit all of the turns and roots that we need to. So take each value, put them into the function x cubed minus 3x squared plus 2 to get our y value just like normal. So if I start in the middle at 0, I would have 0 cubed is 0 minus 3 times 0 squared. So again, 0 plus 2. So my y value here is going to be a positive 2. So hit pause, take a couple minutes, find the other remaining values that we need. So hopefully you put those values in. You can see my y column filled in on the right. And so now what we need to do is plot these points on our graph. If they go off the graph, that's actually a good sign. That means that that's heading toward that's our end behavior sort of at work, especially when it's that, first or last value that we've put in. So the fact that I'm -2, I'm going off the graph down here at -18, not a problem. That just tells me I'm going down off of my graph at that point. So if I start at -1, -2, and then I have 0, +2, I have 1, 0, 2, -2. Okay, so I can already see my graph coming together, right? At -2, I'm way down here somewhere. So my graph comes up, I'm turning, I'm hitting here, right? But I need to go back up off my graph. So I'm just going to add in one more value, right? So we're going to add in that +3. We do 3 cubed minus 3 times 3 squared plus 2. We should get a +2. So +2 is here. So that's that turn coming up. And then obviously I know what my end behavior is supposed to do. So I can just draw my end behavior continuing. You could put in a +4 to sort of verify. But again, knowing what your end behavior is supposed to do, knowing how many turns you have, that's going to help you not do tables of values that go on forever. Okay? So let's go back up here and let's answer some of the questions that we have. If we are looking at describing the roots of the function. Okay, well, remember real roots are where we cross our x-axis. So I have 3 real roots we could talk about, right? So I could even say that I have 3 real roots. And then it's, what are those roots? Well, we did have one that we know exactly because one of my points is 1, 0. So we have at x equals 1 is one of my roots. But then when I'm looking at my graph and at my chart, I didn't have any other x values where y was 0. So what we're looking at is, where do we cross the x-axis? So you can either look on your graph for that, or you can even find this in your chart, right? Where does our y column change between positive and negative values, right? So when it crosses from the negative part of my graph to the positive part, this tells me that there's a root somewhere in between because I have crossed over the x-axis. We did that directly at 0. And so we have another root down here when we crossed again, going from -2 back up to +2 on the y-axis. So when we're talking about our roots, if it's exactly at a number, we state that number, or we have to talk about the numbers it's between. So I have one root at -1. I have one that is between -1 and 0 on the x-axis, right? Because my root fell between. And I have one that is between 2 and 3 on my x-axis. So those are going to be the roots of our graph. This is more about having sort of a sketch to our graph, having an idea where things are, not necessarily those exact values. Estimate the relative max and min. This is where you want to look for what was that sort of top point and bottom point. Where are those turns? Okay. Again, these are estimates to a certain degree, so we're just going to go with our ordered pairs that we kind of made those turns at. So we're going to say that the max is, well, I guess I should be precise. The relative max is at 0, +2. And our relative minimum is at 2, -2. So looking for those ordered pairs where we did have our turns. Okay, so that's the general idea of what we're looking for here. We want to be able to answer some information. We want to be able to make a table, sketch our graph. This isn't about having every point perfect. You're going to have a table full of points that are part of your graph. Again, you're not going to get every root perfectly. Your relative max and min are estimates because nothing says that this doesn't go a little bit up past that +2 value before it turns back down. So we're going with the closest point we have to where those turns are happening. So we're going to take the same approach and we're going to do number 2. So number 2 is x to the 4th minus 8x squared plus 10. And so again, if you want to think about what some of the key characteristics are going to be, this is an even function. That means my end behavior will go in the same direction. Again, it's positive. So that means that my end behavior on the right will go up. That means it's also going to go up on the left, right? So both of my end behaviors, left and right sides, are going to go up. If it's a 4, that means there are 3 turns. So 1, 2, 3. I'm going to be looking for sort of this W shape. So what I'd like you to do is go ahead and start by making our table of values and start with that -2 through +2. So go ahead and hit pause, make your table for -2 through +2. Okay, so you can see my XY chart is there. I have my values for -2 through +2. And so we can start by graphing those values. So -2, 2, 3, 4, 5, 6, -6, -1, +3, right? 0, +10, 1, +3, and 2, -6. But again, I'm not getting that full shape that I need. Think about which direction I'm supposed to be going as my end behaviors, right? These need to sort of turn and come back up. So what we're going to do is take a value on each end. So -3, +3. We're going to put those into our function. We're going to get additional values and see if that gets us our end behavior. If you put those in, they're going to give you a positive 19, which that's promising because I'm going up off of the graph, right? So I know that for both of these at +3, if my graph goes up to 10, then my +3 values are up here off my graph, right? So that's sort of what I wanted to see happen, because that means that my end behavior is up here somewhere. This comes down. Sorry, that went sort of way off track. But you can see this sort of W coming into play. And then this would go back up. Okay, mine's a little wobbly with my mouse, but you get the idea. Okay, good thing we have the exact values in our table, right? So then if we come back up again to our questions, we can describe our routes. So again, we want to think about all these places where we were crossing our x-axis, okay? So think about where our values were. Now, this is where my graph being a little off isn't the most helpful, because if this point down was at -6 at -2, and then at -3 I'm way up in the positive, this should be crossing more in here. If I fix my graph a little bit, okay? But this is where using your table can be more helpful, right? Think about the fact that if here I'm changing between positive and negative, that means my routes between these two values, right? Here I went from negative to positive, so I'm going to have another root in here. Here's positive to negative, so here's a root. Negative to positive, so here's a root. You have a degree of 4. We should be finding 4 roots, right? We are crossing that x-axis 4 times, so I do have 4 real roots. Each one of these is between values, so we are going to have to list what each one is between. So I have between -3 and -2, between -2 and -1. Again, remember you're listing your x values. Between +1 and +2. And lastly, we are between +2 and +3. If we're looking at that relative maxima and minimum, let me slide all of this a little bit and give myself some space here, okay? That means that I'm, again, looking for where did I turn, what were those points, okay? You can have more than one of either one. So my relative max would be at that topmost point, right? 0, 10. And then you would have relative minimums at those two bottom turn points. So -2 negative